Okay, starting the third example. So what's the volume underneath z equals 4 minus r squared? Okay, we have to figure out what that is. And above x squared plus y squared is less than or equal to 4 in the first quadrant. I'm going to let you maybe try to think about this. Take a pause here. It's a good time to attempt to graph something. So, I'm assuming now you've done that. Ready on the pause key at any moment. So what do we do to unpack this problem? I think I need to graph a bunch of things. And so here are the two pictures that I would draw to solve this problem. So the first is a picture for x squared plus y squared is less than or equal to 4. So for that, I'm going to draw in the xy plane. And we all know what that is. That's less than or equal to, okay, well, that's basically a circle. Oh, wait, it's a solid disk. So how would I do that? I would draw a circle. Pretty bad circle. Always going to take 2 attempts at my circles. That looks good. It's better. So it's a circle with radius 2 in the xy axis. And because it's less than or equal to, this is the solid filled disk. Now I only want to focus on the first quadrant. So I think actually my region is this one over here that I'm doing in light blue. That's in the first quadrant. That's inside of this disk, and I can ignore the dark gray sections. And so I want to be above this quadrant in this little quarter of a circle, but underneath this other curve. So let's draw the other curve. And now I'm not going to draw the other curve in 3 dimensions. Even if you can, I think it's pretty easy to see what this is in the ZR coordinates. So if you're at a given radius r, what does this graph look like? Well, 4 minus r squared is equals 4 minus r squared. That's a semicircle. It's a positive semicircle of radius 2. And so we're looking at this region underneath this graph. Now, what you should think about is that r, this compresses the xy plane. So if you want to reassemble the whole plane, you should imagine spinning around the z-axis to see all the different angles theta. And what you'll see is that z equals square root of 4 minus r squared is the upper hemisphere of a sphere with radius, and I really shouldn't say r, with radius 2. Okay, and you can also see this if you plug in x squared plus y squared for r squared. And so that's 4 minus x squared minus y squared. And so those key polar substitutions that we talked about in polar coordinates before spring break, those still matter. Okay, so if you spin this, you should see hemisphere, upper half of a sphere. Okay, and so that's the region now that we're computing. What's the volume underneath this and above this in the first quadrant? And so I could even assemble these into a total picture for the question we're answering, x, y, z. So here's my picture that I drew in the z to r plane. And it also continues over here, but we're not going to need that half. And the xy plane, we have this, I'll draw it in blue. We have this shaded region. And so the region that's underneath this hemisphere, oh, well, let me start making this actually look like a sphere. If it's going to look like a sphere, it should kind of extend like this. And you can see how this is really part of the upper half of a sphere. But we only care about what's above this blue section. And so that's just this first octant portion of this sphere. And to me, that looks like just 1/8 of a sphere. So it's 1/8 of the sphere. And the radii match up here. The sphere that is in the ZR coordinate, that's radius 2. And we're above a disk of radius 2. So really, we're just looking at 1/8 of the volume of a sphere. And so that means the volume is going to be 1/8, the formula that I think everyone should have memorized, 4/3 pi r cubed. That's 2 cubed. 2 cubed is 8, so in fact this answer is exactly 4/3 pi. And we're done. But let's also set this up as an integral, just for curiosity. So what our analysis has told us is that one way to compute 4/3 pi as this volume is as an integral of your volume form, dv. So that's r dz dr d theta. And now theta in these coordinates is going to come from the xy plane. So our smallest theta for that blue region is theta equals 0. And our biggest theta for that region is theta equals pi over 2. Okay? In that region, we're starting at r equals 0. That's the origin. And we go out to the circle, which is r equals 2. And finally, for the z-axis, okay, z is starting at the xy plane. That's z equals 0. And it's going up to this new formula we have. And I'm just going to use the one that we gave for the semicircle, or the hemisphere. So that's 4 minus r squared. If you want to go check it out, and plug these in, you're going to get the same thing. So if you want, you can go evaluate this integral and get 4/3 pi and be happy.